Patreon members and viewers like you make this stuff possible. And also, of course, obligatory warning here. And in today's video, we're going to be synthesizing sodium triacetoxyborohydride, which is an interesting compound because it's a fairly weak reducing agent and can be used to reduce aminium ions to amines. Anyways, so you'll need sodium borohydride of solvents such as 1,2-dichloroethane, however a few others will also work, but dichloroethane is best, and also glacial acid, of course. And here's my stoichiometry if you want to look at it. And the solvent I chose is a random arbitrary volume because there's actually no info on the solubility. All it says is it's fairly soluble. So here you have 1.89 grams of sodium borohydride, which I'll crush up into a powder. An arbitrary amount of dichloroethane, like I said, because you can't find solubility data anywhere. I looked, there's no exact number, so let's just use a random amount that looks good, and we'll add 9.01 grams of glacial acid drop-wise. This reaction is slightly exothermic, but it's not actually that exothermic, as I found out later. And here you can see hydrogen formation as the reaction happens, of course. So let's take a look at what's actually happening here, because it's sort of an interesting reaction. So we have our borohydride here, and it undergoes protonolysis by acetic acid to yield us borane, which is weird. And then the borane then can undergo attack by the lone pair on the oxygen on acetate to yield us sodium acetoxyborohydride. And then that process repeats itself 2 more times to yield us the triacetoxy compound. You can also get di and also tetraacetoxy, but those will not really be in solution there. And here's the hydrogen formation. It's kind of fun. So this addition took me about half an hour to do, and then in the end I put an air condenser on it because it is getting hot, but honestly you don't even have to cool this reaction. And then I brought it up to 50 Celsius for an hour, and this is to drive it to completion. I also did stir it overnight, but I don't think that did much, but you can do that if you want. And here's the solution. You can see the sodium triacetoxy is not actually fully dissolved in it, it's more of a suspension, but it has this nice pearlescent effect. And now we just strip the solvent off under a vacuum using a rotovac because I'm fancy. But you could also keep it in the solution, I guess. And here you can see it forms this kind of paste. It doesn't really crystallize nicely. It forms a kind of dust. But anyways, after removing as much solvent as I could, I got 164% yield, which is not correct, of course. So I went ahead and put the powder back in the flask and dried it under vacuum further. You have to keep this below 100 Celsius. Above that, it starts to decompose. And now I have 106% yield, but that's acceptable. It still smells like dichloroethane, a bit of acetic acid, so I know it's fine. And, yeah, I need funnels. Anyways, you want to cap this stuff pretty tightly because it is moisture sensitive, like borohydride itself is. But honestly, I'm not sure how important it is. Just to store it properly, you know. Don't put it in like a plastic bag. Put it in a nice little jar. And I'll relabel this, of course. And here's our final sodium triacetoxyborohydride. And that's all for this video. See you guys next time. Now, I did actually try using this for reductive emanation, but my emanation failed twice. I don't know what I'm doing wrong, honestly. Maybe I'm just bad at chemistry.